Howdy, today on Flippin Science, we're looking at stoichiometry.
Make sure you balance the chemical reaction and check the coefficients or impression. Then by using the molar mass ratios, convert the moles. Thought I'll let you know. When you choose to take that AP chemistry, you need to know how to do stoichiometry.
So science understanding, we're going to look at knowledge of mole ratios and reactants can be used in quantitative calculations, and you need to perform stoichiometric calculations when given the necessary equation and data.
So what is stoichiometry? Stoichiometry, depending on how you've been taught to pronounce it. So it's the quantitative relationship between reactants and products in the chemical reaction. So if we know how much reactant we're starting with, we can figure out how much product we're going to be producing. So it uses the RMR, which is the reacting mole ratio of the reactants compared to the products, to determine the quantity of materials that you can react or produce or both in a chemical reaction. So when we're answering stoichiometry questions, oftentimes we'll have to use a couple of equations. The main one we're going to be using to figure out number of moles and also masses is this one over here. So number of moles of a substance is equal to the mass of that substance divided by the molar mass of the substance. We can rearrange that equation. Often we might need to find a mass. So mass of a substance equals the number of moles of that substance times its molar mass. Very rarely would use this one, so we're not even going to talk about it. In terms of solution chemistry, often we might have to use C equals N over V. So the concentration of a solution is equal to the number of moles of substance dissolved in that solution divided by the volume of that solution. And the other rearrangement we commonly use is the number of moles of substance is equal to the concentration times the volume. So they're the equations that we're going to use for this section. I've got other videos going through how to use these, particularly when we're looking at titrations. Here's a question we're going to answer using stoichiometry. Fuel cell car has a 100 kilogram fuel tank. What mass of oxygen is needed to react with 100 kilograms of hydrogen gas? And then also what mass of water is produced? So to start with this, we're going to write the balanced equation. So we're going to have hydrogen plus oxygen goes to water. Then we need to balance it. So we're going to need 2 of these and 2 of these. So we've got 4 hydrogens in total, 2 oxygen and 2 oxygens. So then we need to figure out the number of moles of hydrogen in a 100 kilogram fuel tank. So number of moles of hydrogen gas equals the mass over molar mass. So 100 kilograms, now we need to turn it into grams. So we've got 100 times by 1,000. So we've got 1,000 grams in a kilogram, we've got 1,000 kilograms, divided by the molar mass of hydrogen. In this case, it's H2, hydrogen gas, so that's going to be 2 times 1.008. Okay, and then I'm going to chuck that into my calculator. So 100 times 1,000, guess what? It's 100,000, who would have thought? Divided by 2 times, bracket 2 times 1.08. And I get 49,603. It's going to be moles of hydrogen. Okay, so now that we've got that number of moles, we can figure out how much oxygen we're going to need. We need to look at our reacting mole ratio. So with a nice balanced equation like this, we can see we've got 2 moles of hydrogen gas reacting with 1 mole of oxygen. So now we can figure out the number of moles of oxygen that we need. So number of moles of oxygen is going to be our number of moles of hydrogen, and that's going to be divided by 2. So why am I dividing it by 2? So our ratio is 2 to 1. So I've got 2 moles of hydrogen gas to 1 mole of oxygen gas. So what that means is I'm going to have half as much oxygen as I'm going to have hydrogen in terms of my number of moles. So I'm going to take my 49,603, I'm going to divide that by 2, equals. So divide by 2, and I get 24,000. 24,800, and I'm going to round off that one to moles. Okay. From here, I can figure out my mass of oxygen. So mass of oxygen equals N times my molar mass. It's going to be 24,802 times by it's going to be 32 because we've got 2 oxygens. So times by 32. I'm going to divide that one number by 1,000 to get me back into kilograms. 793,651 grams. So divide by 1,000. 790. Now we had, how many significant figures we have? We've got 3 here. So we're going to go to 3. So 790 rounding off to 4 kilograms of oxygen gas. So that's the number of kilograms of oxygen gas I need for a 100 kilogram hydrogen gas fuel tank. The other question we've got here is, what is our mass of water? So I'm just going to empty out some of this and have some working out space. So the second part of the question is asking what mass of water is produced. So to figure that out, I'm looking at my molar ratio between my number of moles of hydrogen gas and my number of moles of water. And it's a 1-to-1 ratio. So 2 to 2 is the same as 1 to 1 is the same as 3 to 3. So I need to figure out my number of moles of water, and from there I can figure out my mass of water. So the number of moles of water is going to be equal to the number of moles of hydrogen because it's a 1-to-1 ratio. So 2 to here, 2 to here. So therefore my number of moles of water is going to be 49,603 moles. So now I've got my number of moles of water, then I'm going to multiply that by the molar mass. So number of moles of water, mass of water equals number of moles times molar mass. So it's 49,603 times by the molar mass, which is going to be, what is it, 2 times 1.008 plus 16. So it's going to be 49,603 times by, so it's going to be 18.016 grams per mole. So I'm going to grab out my calculator and do that calculation. So after some furious tapping, I get 893,651 grams. I'm going to divide that by 1,000, turn it to kilograms, so it's 894 kilograms of water being produced. So again, I'm going to 3 significant figures because I had 100 as my number here. So I'm going to produce 894 kilograms of water from 100 kilograms of hydrogen. Let's look at one more example. So the next question is interesting. We're dissolving iron in sulfuric acid. We need to find out how many moles of iron we have, how many moles of sulfuric acid we have, and then determine the limiting reagent. So the limiting reagent is the reagent that will run out before the other reagent does. So we can do that using our reacting mole ratio. So the first thing we're going to do is we're going to write down our reaction. So iron plus sulfuric acid. Now we're going to assume we're making iron 2 sulfate, so that's FeSO4 and hydrogen gas. Let's have a look. I think we're okay in terms of balancing that. Yes, we are. Okay, so 1 iron, 2 hydrogens, 1 sulfate. Okay, so let's figure out the number of moles of iron. So our number of moles of iron is mass on molar mass. So our mass is 5.0 grams and our molar mass is 55.85 grams per mole. So I'll hop on my calculator. So 5 divided by 55.85. I get 0.0895 moles. So I'll just go to those 3 significant figures there. I've got 2 here and 4 here, but we'll just go to 3 to start with. We'll keep the big number in our calculator. Then we figure out our number of moles of sulfuric acid. N equals concentration times volume. So our concentration is 1.5 and our volume is 500 mils. So we need to turn that into litres. It's going to be 0.75 moles. Okay, now we need to figure out what our limiting reagent is. So to do that, we're going to look at how many moles of sulfuric acid we need for the number of moles of iron that we have. Then we're going to look at the number of moles of iron that we need for the number of moles of sulfuric acid that we have. What that means is our number of moles of iron in this reaction, we're going to use all that up. Now that's going to be equal to the number of moles of sulfuric acid that we're going to use. It's going to be 0.0895 moles. So if I had 1 mole of iron, I'd need 1 mole of sulfuric acid to dissolve it. In this case, I've got 0.0895 moles of iron, so I need 0.0895 moles of sulfuric acid, which is much less than the 0.75 moles that we have. Let's have a look at our ratio of sulfuric acid, so we're just going to rewrite this a little bit differently, of sulfuric acid to iron is also 1-to-1. So if we had, so our number of moles of H2SO4 to our number of moles of iron, so that would be 0.0895 0.75 moles. So what that means is if I had 1 mole of sulfuric acid, I'd need 1 mole of iron to react completely. In this case, we've got 0.75 moles, and I would need 0.75 moles of iron to react with that to completion. So what that means is we have far in excess of sulfuric acid. We have far more sulfuric acid than iron because we have far more moles here than here. So we would use up 0.895 moles of our sulfuric acid from our solution.
5 grams of iron.
So today in Flipping Science, we looked at stoichiometry and using the reacting mole ratio. That's it for Flipping Science today. Bye!